Hi everyone, this is David. Today I will share with you a Python script that to draw a projectile trajectory at different angles, 45 degree and 60 degree, with the same speed, initial speed, the 10 meter per second, at the same ground height, which is 0 meter, and to display the landing time, the maximum height, and the landing distance. This is an application of a quadratic equation that I mentioned before. Now I'll show you something that you can see the difference when you draw them at different angles. So first we're going to do all script, the same like when we do all the quadratic equation. These are all the packages that we require. We're starting the time at the computer to turn on the stopwatch. I got to measure how long it takes. You see the 9.8, this is called a gravity. But gravity measured by meter per second square. This is agree. I think that they are agree accepted for our study. Initial speed when we start the same with 10 meters per second. So they run two angles, 45 and 60. So you can see with the color blue and orange. The 45 blue and 60 when you orange color. Easy to see. So what we're gonna plot it, right? We prepare plotting on for the figure size and projectile of 45 degrees, 60 degrees, horizontal distance and vertical height. So this is the code that we're going to draw from the angle, the color, right? We will angle we measure radian. I cause angle I think a bit more complicated as size. This one you learning school you probably know can tell the difference. And time of flight until landing, the T fly. And then generate time point. That orders, I think that the packet work area for us. So the quadratic equation x v times t, vy that minus 0.5 g t squared is a t squared. So we plot it. So what we see here, I'm going to show you the very quick result. They're going to print already, and this script is processed very quick. Look at it. You're going to run it. You can see that this is the outcome. This outcome, let me explain this outcome. Quite interesting there. Look at it. You see there's a color here for 60 degree. 60 degree, you draw it go higher. And 45 degree, now here. 45 degree, we draw the angle 45 degree. So you can observe that very clear. We start with a 45 degree, for 1.44 second, it will end up 144 second. When you draw it lower, 45 degree, which is lower, 60 degree is higher, so it takes long time. When you draw higher, it takes longer time to land, 1.77 seconds. But the high point, when you draw it low, right? When you drop low, cut a high one is low as well. So the high point here is 5 horizontal here, right? This is the high point at this point here. Compare the high point here for the 60 degree is higher, right? You can see that quite clear as a high position here. And the distance too, you look at the distance, with a 45 degree, you got a longer distance, right? You got a longer distance, 10.20 meter. Where you got 60 degree, when you're high, of course the gravity pull you down quicker, therefore the landing is 8.84 meter. So you can see the difference. This is the quadratic equation application. We set up in this image when you draw the angle, the smaller angle you draw, the further distance you travel, right? I did got common sense too. You can see when you draw something, to the sky, and then you expect this sort of pattern that coming down. In reality, there will be some impact on the wind as well. Sometimes the wind will make some variation, so that will be another variable need to introduce in this. And for the simplicity, we just look at the drawing the objective with the angle 45 degree and 60 degree. Right, that's the application of the quadratic equation. I hope that you understand that and you enjoy this graph. Thank you very much for watching. I'll see you next time in the next video. Thank you. I'll quickly, look at how long it takes. They want to go very quick too, 148 seconds. Total computing time is 148 seconds. All right, this is very quick. It's 2 minutes. We can get all done in 2 minutes, which is quite quick. All right, for two different angles.